Hey there everybody, welcome back to my YouTube channel. So today we are back with another virtual internship program which is by the Let's Grow More community with the data science internship program. So as part of the program we have the first task which is the iris flowers classification. So let's understand a bit about the iris dataset. So the iris dataset is a multivariate dataset. It was introduced by the British statistician and biologist Ronald Fisher in his 1936 paper, The Use of Multiple Measurements in Taxonomic Problems as part of the linear discriminant analysis. Now, what linear discriminant analysis is, it is a statistical technique or a method that you can apply in order to obtain a linear combination of features which can help you in classifying or separating a particular set of objects based on the class. So this particular data set is considered to be the basic or the starting point of any data science data sets because this data set is perfectly good for classification as well as clustering. This is the ideal data set, you could say. Now, sometimes it's also called the Anderson-Cyrus data set. This is mainly because of Edgar Anderson who collected the data. Now, he collected data based on three species, Iris setosa, versicolor, and virginica. Now, in our particular data set, we have four features with which we'll be using to classify. So we have the length and width of the sepals, length and width of the petals as well. Next, we can see that we have imported the relevant dependencies. So first, we have imported NumPy and Pandas along with Matplotlib for visualization. After that, we'll be loading our data set. So I have the iris.data extension. So .data, we'll be reading that in readcsv as well. So you can just see that you have your four columns along with your target variable here. The dimensionality of the dataset is 150 observations with 5 columns. Now, 150 observations means it's a pretty small dataset, but one important thing since I've gone ahead with this, I know is that there are no class imbalancement. Like I said, this is the ideal dataset, perfect for anyone who is new to data science. We'll be performing a basic EDA. We won't be going much in depth into this because of the fact that this is a ideal dataset. So we can see first we check for the missing values. We can see there are no missing values, so this is actually good to go from here. Next, we'll be looking at the pair plots. Now, one distinguishing feature about the pair plot is that you can see Iris setosa, the red color, they have clustered themselves as a separate group. But versicolor and virginica have not. Like you can see that they are overlapping each other. Now, this is the main problem of this particular data set. So, in case you're doing cluster analysis and you haven't given this color coding, you can only see two clusters. You can't find there are three clusters. So I think it was Fisher who actually gave the importance of species to be played while clustering. So that is why we can get three clusters here. Next, we'll be performing our model building phase where we will be initially going to obtain our independent variables and dependent variables. Our independent variables are the length and width of the sepals and the petals, and our dependent variable is our species or the class. We'll be encoding a target variable. So we've given iris setosa as 0, 1, and 2. By default, label encoding encoder does that. So we don't have to worry much about that. Next, what we do is we obtain the train and test. So here we can see that we've used the train test split from sklearn. We've got a training size of 80% and test size of 20%. Next, we'll be focusing on the model training stage. Now, this is where I have three important procedures where I go about. First, I fit the model and I obtain the normal accuracy, the initial accuracy. Then I perform K-fold cross-validation. Now, cross-validation helps in reducing overfitting. Not that it is of any importance here, but you can always apply this in any data science projects. Next, I find the overall accuracy. So I've used a random forest classifier, and with this I've got an accuracy of about 100% initially. Then with tenfold cross validation, I've got 93%. So you can see that from 100% it's reduced to 93%. So after that, I'll be using this because it's much more appropriate. 93 is much more, you can compare it. 100 is like out of the world. So with that 93%, I'll be predicting my particular test data set, and I've got an accuracy of 96%, which is actually pretty good. I mean, anything above 90% is actually obviously good. So there are different methods that you can try out in this. You can definitely try with other models, or you can find which model is best suited for this particular data set using the lazy predict. Now that's a library which you can explore. It's damn good. So yeah, that's all from my side. Thank you.